Hello everybody, in this video we are going to continue the conversation about quadratic transformations. So in all of the previous videos we have talked about what a parent function is, what vertex form looks like. We've talked about reflections, which is a change in direction. We've talked about vertical stretches and shrinks, which changes the width of your graph. We even took a moment to talk about a horizontal translation, which doesn't reflect, doesn't compress or stretch your graph, but it moves your vertex from the left to the right. So the last thing we're going to talk about is a vertical translation. So if we can move a graph to the left and to the right, we can also move our graph up and down. So that's what a vertical translation is, moving a graph up or down. So notice at the top I have written our vertex form. And the one number that is solely responsible for moving our graph up and down is going to be the k. Notice that the k is not inside the parentheses, it's on the outside. And it's also being added, or it could also be subtracted. That number right there is going to move our graph. It's going to move our vertex. So let's read what we have here. Okay? So a vertical translation is a shift to the up or the down. So there's an extra word in there, ignore it. In a parabola, vertical translation is caused by the change in k. So if we change this k value, it's going to start moving our graph. And so if we have a negative k, it's going to move it down. And if we have a positive k, it's going to move it up. So that's it. That's simple. It's not going to change the direction. It's not going to change the width. It's just going to take your vertex and move it up or down. So let's look at a couple examples. I do want to remind you that this video is going to be much more productive if you already have these graphs. So that way we can focus on our conversation. So if you do not have these graphs already on your coordinate planes, I encourage you to pause this video, graph both of these functions, and then unpause the video so you can listen to the conversation. All right, with that being said, let's go ahead and look at these. So if you already have your graphs here, notice that I'm using the same quadratic function that I've been using through the entire series for these set of notes. This is my parent function right here. This is my parent function. I'm using the same graph and the same points, and that's what we're comparing it to. All right, so if you look at your parent function in the first one, we don't have any extra numbers here. We don't have anything that's being added or subtracted, so it's an automatic 0. So k for the parent function is 0, and I wrote that in for all three of them. Now if I look at g of x, I do have this plus 1 at the end, so notice that I'm saying k is equal to 1. Because it's a positive 1, we can look at the graph and compare the vertex. The vertex is going to be your point of reference. So here's my original, and here's my new one. And if you look closely at that, you can see that the new vertex has been moved up 1 unit. So we're going to write that in. So at the bottom here, we're going to say g of x is shifted up 1 unit. So when you get to this part in your notes and it's asking you to identify the vertex, you can do it by looking at the graph, but you can also do it by looking at the equation. All right, let's look at the second example here. Notice that this is k is equal to 0 because there's no extra numbers here. And our g of x has this minus 2 at the end, so k is equal to negative 2. If you look at the graph and you compare the original vertex to the new vertex, you can see that the new vertex is 2 units below the original. So we're going to say that g of x shifted down 2 units. So the number tells us the distance. The sign tells us the direction. So it's telling us two things here. All right, last one. So once again, our parent function, k is equal to 0. And then our g of x has this plus 2. So k is equal to 2. So the plus sign tells me it's moving up, and the 2 tells me how far up, 2 units. So if you look at this graph, here's my parent function, here is my new function, and we can see that it is 2 units above. So for this one, let's write it out. G of x shifted. We should really use the word translates. G of x translated, or translates, up 2 units. Okay. All right, so with that being said, that is a vertical translation. So anything that has the word translation in it, it doesn't change the direction, it doesn't change the width, it just takes your vertex and all the points in the graph and moves it up, down, left, or right, depending on where that number is located. So I'm just going to remind you that if the number is just being added and subtracted kind of out in the open, this is a K value and it's moving up or down. And then, just to compare, if you have a number that's being added or subtracted but located inside the parentheses, then this number is either going to move it to the left and to the right. And remember what I told you. It is going to do the opposite of what we naturally think. And if you're confused about that, graph them and look at them on the graph so you can see, did it move to the left or did it move to the right compared to the parent function. And that is it. That is the last section of our notes. I hope that these examples and these explanations have helped you feel a little bit better about what each number does in the equation to the actual graph. Okay? With that being said, y'all enjoy the rest of your day. I'll see you guys in the next video.